of 100 divided by log 8. Or you could have done ln 100 over ln 8. Notice that the base here is 10 and 10, which there's a calculator key for that, and E, where there's a calculator key for that. All right, so we decided that we're going to go backwards and work towards the front because we started at change of base 6 period, and that way you'll have more online. So you're going to have one logarithmic application, and I'm not really, this is still exponential, in my opinion. But anyway, the number of flies at time t, where t is measured in days, can be modeled as, where f is the number of flies. First question, and this should be an easy question, is this growth or is this decay? How do you know? Because 0.5493 is what? Positive, okay? So that is growth. Now, when are there, I can't separate those, so this is B. When are there 230 flies? Where do you put 230? You got two choices, F or T. F, because flies is not how we measure time, is it? It's not 3 flies from now, we're going to go to the store. Or 2 flies from now, we're going to go to prom. Correct? That does not make sense. So we have to say 230 is equal to 100 e to the 0.5493. Now this speaks to the exponential equation that you solved before I started this. All right, we have to get e by itself, so what do you do? Because whenever you have t as an exponent, the exponential part, which is this, must be isolated. You cannot log both sides so that 100's gone. How do we get rid of it? Pardon? No, we cannot natural log as long as there's 100 there. It has to be strictly the exponential part, which is in parentheses. So how is 100 attached to e? Multiplication. So how do we undo multiplication? Division. So we're going to divide. So when we divide by 100, we're going to get 2.3 is equal to e to the 0.5493t. Now that's isolated. Now what do we do, Nicole? Yes, now we're going to natural log both sides. And when you natural log both sides, properties of log says this goes where? Out front. So this is going to be ln of 2.3 is equal to 0.5493t ln e. What's ln e? 1. So that's going to be gone. So now how do you disconnect this from t? Divide by 0.5493. Now when you do this, when you hit your ln button, it should come up with the parenthesis. You must close that parenthesis before you hit your divide key. And I think this was maybe 1. It wasn't very big, I don't think. What is, anybody do it? 1.51. So in about a day and a half, there's 230 flies. I guess that's quite a bit of multiplying. All right, so the next question was, how many flies are there on the 15th day? Now, what does 15 represent? If this represents t, where does it get substituted? For what? T. So we're going to say f is equal to 100 e to the 0.5493 times 15. All right, so the reason why this is called a logarithmic application is because we had to apply the natural log to do some of the solving. Do you have to do natural log here? No, you just chunk it in your calculator. Make sure that this exponent is in parentheses, or it will raise e to this power first and then multiply the whole thing by 15. And I think that was an astronomical number of flies. Day 1, there was what, 230? Now how many do we have? Who's got it? 3,787? Okay, so we got 2/3 of a fly. In 15 days, we're inundated with flies. What? I would probably, is it a backwards calculator? So I would do this first and hit equals. Then I would do second ln because that raises it to the e power. And I would hit equals. And then I'd multiply by 100. Oh, that's, okay, hold on. That's just the e part. So it's not 3,787. It is 37,876.4 flies. We need some frogs, some birds. No. You're here today. You will be here today. 6'4"? You mean there's 378,000 flies?
Oh, yeah.
Okay, we need some bug-eating birds, reptiles. It's probably y to the x, underneath off. Okay, so working backwards. Now, we're going to graph. You ready? Oh, but we are. So you better get ready because I'm moving. Which one do you want to do first? Don't you have a scrap sheet?
Well, graph paper.
You don't have a scrap sheet? All right. Which one are we going to do first? Wait a minute. I know. That's my question. Nobody has said, do you want me to do the left one first or the right one first? It says graph using transformations and exponential or a logarithmic. So you have one on the test.
Oh.
We have time for both. So let's do this one first then. You ready? This is the exponential one. So what? But first, it's with transformations, and you all know your transformations. That's not the issue. What is the parent function? Y equals 2 raised to the x power. Now remember, I didn't give you a quiz on this because every time the base changes, the graph has different numbers. So we do -2, -1, 0, 1, 2. Do you agree that it's easier to substitute numbers for x than for y?
Wait, so it's always going to be?
Unless you have base 10 and then 10 to the second is 100, and I wouldn't want to graph that.
So if -2 was 10, would it be 10x?
It would be, if this were 10, it'd be 1/100th.
How would you know what parent function is?
Oh, it's right there, the base.
Okay, so if that was 10.
Then it's y equals, yes. So 2 to the -2 is 1/4. 2 to the -1 is 2 to the 0, 2 to the first, 2 to the second. Okay, so listen to you all. You know how to do that. Okay? So you've got -2 up 1/4. You've got -1 up 1/2. You've got 0, 1. You've got 1, 2. And you've got 2, 4. Where's the asymptote? I want to see the asymptote. You're going to get credit for drawing in that asymptote. Now, what am I supposed to do first with those dots? Reflect over x. So this barely gets reflected. That's very small. We got here, here, and there. All right, now what do I do with the pink points? Is that left? Right one. So this is going to come to here, this is going to come to here, that will go to there, that will go to there. And then what do I do to all those points? Up 3. And yeah, let me move that. I don't know if I don't remember doing this. So we're on blue. 1, 2, 3, and it's going to be close. Then we're going to have 1, 2, 3. Then we do 1, 1, 2, 3. We do 1, 2, 3. I think that was what it should look like. Yes, reflections first. And I don't think I did that right. That should be there. This should be there. And 1, 2, okay, there we go.
Is that like blue one? Part of the green?
This is all,
Yeah.
yes, because we went 1, yes, it is.
What do you have the x minus 1 after the exponent?
Say that again.
The x minus 1, how do you do that?
This is 1 unit to the right, and this is up 3. Pardon? That too? No, because it's part of the parent function. You know, like the x squared? We don't do anything with the squared, because that's the parent function. You know when we do cube root x, we don't do anything with the cube root because that's the parent function. Okay? So now, my suggestion to make this easy on the log one is to rewrite this as y equals log base 3 of x. All right? That's the parent function. This stays, and I have x. What is happening, by the way? Left 2 and down 4. All right. So now, I think it's easier to find ordered pairs if you rewrite this in exponential form. So this is going to be 3 to the y equals what? Now, what is easier, solving or substituting for y or for x? Yes. So instead of putting -2, -1, 0, 1, 2 for x, I'm doing -2, -1, 0, 1, 2 for y. And then when I substitute it, what's 3 to the -2? 1/9. What's 3 to the -1? 1/3. What's 3 to the 0? 3 to the first? 3 to the second? Okay. So now I need another. So now we're going to graph those points. So I'll start in black. What do we have? We go over 1/9 and we go down 2. That's really close. We go over 1/3 and we go down 1. We go over 1 up none. We go over 1, 2, 3 up 1. And then 3, 4, 5, 6, 7, 8, 9 up 2. Where's the asymptote? Y-axis now. All right, now what do we do to these points? What do we do to them? Left 2. So we're going to do 1, 2. What happens to my asymptote? It goes left 2 also. Okay, then what? Down 4. So we're going to, what color? Green. So now 1, 2, 3, 4. We've got 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And 1, 2, 3, 4.
There's only one asymptote for each graph.
Yes, only one asymptote for each graph.
Asymptote?
Well, it was here, but because
What
we,
is that?
y equal, or x equals -2. Is that what you're asking?
No, why is it -2?
Because the whole graph moved 2 units to the left, including the asymptote.
Oh.
And see, when this was +3, the asymptote also moved up +3. Okay, so there's the graphs. Moving backwards, we come up with our applications. I will give you these formulas, but I will not tell you what they're used for. That was my compromise. Okay? So, what is this one for? Compound interest. What is this one for? Future value. We did. Then you didn't do those problems on the homework.
Did they give you a different equation for that?
They also gave us A equals PE to the RT, but that's compounded continuously. And this is compounded what? Right. Now, some people have been fussing about these 2 word problems. My point is, these 2 word problems don't get any easier than what they are because all you have to do is literally what? Substitute. That's it. What is P? 12,000. No, it stands for principal. That's the money that you deposit. What is R? 0.073. Why isn't it 7.3? It's a percent. We got to do it as a decimal. What is N? No.
Oh, 12.
12. Where did you get 12? Monthly. Compounded is N, and monthly is 12, quarterly is 4, semi-annually is 2, daily is 365. What? How many times is compounded? Ask the person who wrote the formula. So then we're going to have N, which is 12 times what? 5. So I would always put this in parentheses because you want to, otherwise it might raise it to the 12th and multiply the answer by 5. So now all you have to do is put that in your calculator. And this was 17,267-ish, I think. Don't quote me on it. Did you do it? Okay, so point something. 0.06. 6 cents. This is money. We want to get our pennies, correct? We do. We want every cent they give us. Why did the X underneath off or on? Is it there? X to the Y. That's your exponent key. If you do 2, X to the Y, 3, what do you get?
In front of it. Like, say you go to the ln 5, you do 5.
8. It raised it to the third power.
So you have to do that. Yeah, that's later. I mean, it's not.
All right. So now, what are we going to do for our inflation problem? This is future value. What do we do? What are we going to do here? This is even easier than what you just did. You just got out of college, you just got a new job, you just bought a condo for $78,000. Property is appreciating at 4% per year. If you kept your condo for 10 years, how much would it be worth?
Okay, so 78,000.
78,000.
Is that always going to be inflation?
Well, or present value, appreciation, 1 plus 0.04. Exactly. So you're going to do 78,000, 1.04 to the 10th, and that is going to be 115,000-ish. I don't know. I don't remember those three numbers. 459.
5 cents.
459 and 2 cents. 5 cents, right?
How is it 459? Oh.
Okay.
Wait, how are we going to know which equation to use?
That's your job to figure out.
Compounded.
Compounded is a key word, isn't it?
Yeah, so basically we just use the other one when it doesn't say compounded.
Right.
Are there any continuous ones?
Apparently, well, this is PERT.
Yeah.
So I don't think I did it in the other one. So now, this is similar to the the log thing we did. Population in Statesville can be modeled by this equation where A is population in thousands. Now we're going to talk about that. And in 2005, that's T0 is 2005, time is in years. You ready? Is this population increasing or decreasing? How do you know? Because 0.02 is greater than 0. Now, what will the population be in 2015? What is T? 2015 minus 2005, which is 10. All right. So where do we put this in our equation? You either have a choice of A or you have a choice of T. Why does it make sense to put it in for T? Because it's time. Now, that is strictly substitution. These problems are actually easier than the equations that you've been doing, the expansion of logs you've been doing, and because you see words, you have major BFOs. What did you get here? Big freak out. What is it? 8712. Now, does that mean that the population is 42 people? What does this mean? 42.8712 thousand people. Then you get points taken off. What else could you do? Could you tell me 42,871? 0.2. Second trimester, no, second month of pregnancy. Is that what we're doing? Or 2 days from dying? Okay. How do you have 2/10 of a person? Okay. Now listen. Shh. Look at this. Okay? When you put this into this formula, it does not come out this big. It comes out to 42.8712. And then this tells you that that's 1,000 people. So if I had not written this as 50,000, what if I had written that as literally 50,000? Would you be substituting 50,000 in for A? No. You would only be doing 50 in for A because A represents what? In thousands. All right? So I'm just letting you know because I might have done that. So we're not going to do that. All right? So where does the 50 get substituted? So we have 50 is equal to 35.1 e to the 0.02t. You know what I'm thinking? Is I'm thinking in the exponential section, we only did this type of problem, and in the logarithmic section, we did this type of problem, and I put them together. So how do you solve? How do you rescue t? Divide by 35.1 first, because that exponential piece is not what? Isolated. So notice 50 got divided by 35.1 before any lning. Now what are you going to do? Natural log of the left, natural log of the... So, what does the natural log do to the right? It allows that exponent to come forward.
And that's 1, so that cancels.
And that's 1. So now how do you solve for t? First you have to do ln. If you're on the backwards calculator, you have to do 50 divided by 35.1 equals, ln equals, and then what? Then divide by 0.02. Right, hundreds place. What was this? 40. What was the time? And 17.691 thousand people. Are we still on people? What is this? Oh, it's time. So, now wait a minute. Let's look and see. Ready? Let's look to see what it asked. Did they say in how many years, or did they say what year? Oh, so what do? You're at 2005 to start, right? And 17.691 gives you 2022, so a little beyond halfway point of 2022. Yeah, like July. July would be good, because that's over halfway.
That's funny.
All right, so this is done online in a video, and I'll put it on the YouTube. You have to go through Portal or the web page to get to the YouTube. This is also online. Those are online, and that is online in video format.